Okay, so today we want to talk about our conic section, or we'll talk about circles, which is another one of our conic sections here. The first thing that we're going to sort of start from here is the standard form for a circle with a center at hk is x minus h squared plus y minus k squared equals r squared, where r represents the radius of the circle. Okay, now, so what you're going to do is basically to graph these, you plot the center, you use the radius, you go up that many units, down that many units, right that many units, and left that many units. And that gives you 4 points. Draw a circle, call it a day. I guess you could use a compass if you wanted to draw a really nice circle, but usually we just kind of take a shortcut there. So let me run through just a few of these problems on this note packet here, and I'll leave the rest for you to try. For number 1 here, we have x minus 5 squared plus y minus 2 squared equals 4. Right, a nice equation of a circle here. So with this, as we look, well, just like we saw with parabolas, if you have x minus, that's going to show you what h is. Right, so in this case, our center, which is hk, would be 5, 2. And in this case, our radius is going to be the square root of 4, which is going to be equal to 2. That's how we're going to do that. A little bit of a difference between parabolas and circles is with parabolas, the vertex was actually a part of the shape. Here the center's not. The circle's the actual points along the outside. They're all equidistant from the center. That's kind of how we can define it. So let's look at how we could sketch this. So there is our point 5, 2, which is our center, right? And then I'm going to go 2 units to the right, 2 units to the left, 2 units up, 2 units down. I'm going to do my best to draw a circle there. That's what that graph would look like. Okay, for our next example from the back of the worksheet here, you're given a graph of a circle. I tried to make a picture of that circle. Assume it's a circle. But as we look at this, we know that to write the equation, right? We just talked about the form being x minus h squared plus y minus k squared equals r squared. We need to know where the center is at to get h and k. And then when you know where the center's at, you can find the radius. So the first thing we have to do is figure out how do we find the center if we're not given it. The easiest way is if you have some diameter, right? So what we can do on our picture is we can look, and it looks to me like the left edge here is this is at -2, -4. And then over here we are at 8, -4. Right? So that's a diameter. We can see from our picture, right, that would be the left edge to the right edge. The same thing as here, we can see that this is 3, 1, and that this is 3, -9. What we should be able to do is we could just find the midpoint between these two extremes, and that should show us where the center's at. So the way we're going to do that is to find the midpoint of -2, -4, and 8, -4. We're going to go ahead and do -2 plus 8 divided by 2, and then -4 plus -4 divided by 2. You just take an average of the x's and the y's. Don't subtract, you just add them together, divide by 2. So here we get 6 divided by 2, which would be 3, and then here we get -4. Now, if you have all these points, we also could tell that these are both 3's, correct? So this would be 3 in the middle, and these are both -4's in the y position. Or you could do the average. The average is nice. If you're ever told you have a diameter, maybe it's not horizontal or vertical, so you really don't want to have to try to reason it out. You just take the average of it. Is a nice thing to do. If you see later on, it gives you some diameters. So here we have the center is at 3, -4. Now once we know that, we know h, we know k, now we just have to find r. And if we look, this is 5 units, this is 5 units, this is 5 units, and luckily this is 5 units. They should all be the same, right? If they're not, then we didn't find the center. But we see here that the radius would be 5. And again, 3, -4 would be HK, would be the center of our circle. So our equation would be x minus 3 squared plus y plus 4 squared equals 25, right? Because 25 would be r squared. Any questions on that? No? Okay, this is on our worksheet here as well. We're given this equation. This is a quadratic, right? Except a little different. It has x's are being squared and y's are being squared. So what we have to do here is we're going to complete the square, which is something we did in the past. It's going to be a little bit different feeling here. But we're going to have to complete the squares for the x's and for the y's, trying to get in our standard form equation for a circle. And as we look at other conic sections, we'll have this same type of problem, but it might, you might be given something like this and have to determine, is it a circle? Is it an ellipse? Is it a parabola? Is it a hyperbola? All that stuff. So just to remind you, completing the square, the process is if you have something of the form x squared plus bx, what you're going to want to do is you're going to want to take half of b and square it. So you add b over 2 squared to that. So you get x squared plus bx plus b over 2 squared. And then this always factors to become x plus b over 2, the quantity squared. So if you remember, an example would be maybe you have x squared, I don't know, plus 12x. So you take the number 12 and you cut it in half, gives you 6, right? So what we want to do here is if you add on 36, then it factors to become x plus 6, the quantity squared. That's the completing the square process. So we're going to have to do that here. Now, you can't just add 36 to an equation and it doesn't stay the equation. So what we're going to see is we're going to probably want to add a number to the left side and to the right side to get this to work. So we see we have an x squared minus 8x. We see we have a y squared minus 10y. This plus 37, I'm going to recommend that we just subtract 37 from both sides right now. Just get it moved out of here. And this process is probably a little different than things we've done before. But as we look at this, if we have x squared minus 8x, what number completes the square here? So you take half of -8, which is -4, square it, you get 16. So I'm going to go ahead and add a 16 to the left-hand side. In a minute, I'm going to add a 16 to the right-hand side also when I write that out. And then how about we have plus y squared minus 10y. What's half of -10 squared? Would be 25, right? -5 times -5 is plus 25. Now, because we have an equation, because we added 16 to the left side, we have to add it to the right side. Because we added 25 to the left side, we have to add it to the right side. Keep it balanced. Good. Now at this point, this factors, correct? So we're going to get x minus 4 squared, and then y minus 5 squared. That gives us 4, I think. So that's what our answer would look like. So again, completing the square we did earlier in the year. We did it more for solving quadratics. But with these conics, it comes up a bunch where you get this sort of thing and you have to get that to work. Any questions with that? So again, just remember, I would get any constants to the right, figure out what you need here, figure out what you need here, then just add it to both sides. And it should work out pretty well.